Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at more examples of finding the derivative of sine and cosine functions. In the previous video, we looked at finding the derivatives of the cosine function and the sine function, and those derivatives can be written in this form. So the derivative of sine of u with respect to x will be equal to cos of u times du dx, and that du dx is very important. That comes from the chain rule. The derivative of cos of u with respect to x will equal negative sine of u du dx. So what I want to do in this video is just look at more examples and get ones that are a little more challenging than in the previous video. So we have an example here of 10 times sine squared of 3x times cos cubed of 4x. So it's a product, and in each of the factors there's a power. So we're going to use our product rule first, and I wrote that at the side for you to refer to. And I'm going to identify, I could leave the constant out front and not even include it in the product, or I can include it in my factor u. It doesn't matter, it'll be the same either way. So if we include it, that's going to be 10 times the sine of 3x, and the way I want you to think of that is that the sine function is squared. So we're going to put that outside so that it's more clear that that's a power. Then when we differentiate this, it's going to be 10 times 2, which is 20, times sine of 3x to the power of 1. 2 minus 1 is 1. Then we go inside and we multiply by the derivative of sine of 3x, which is cos of 3x. Then we go inside the sine function and we multiply by the derivative of 3x, which is 3. So lots of functions going on there. First of all, power, then sine, then 3x. So the derivative of each of those should be included in your whole derivative. We do the same thing for v. V will equal the cos of 4x cubed. So it's a power first. So v prime will equal 3 times the cos of 4x squared. Now we go inside the power function. The derivative of cos of anything is negative sine of 4x. And then we go inside the cos function. We have 4x. The derivative of 4x is 4. Now that we've got these, I can plug into my product rule. The derivative will be equal to u times v prime. 3 times negative 1 times 4 is negative 12. Cos squared of 4x, sine of 4x. Plus v, which is cos cubed of 4x, times u prime, which would be 20 times 3 is 60, sine of 3x, cos of 3x. Let's just clean it up and see what we've got. 10 times negative 12 is negative 120. I have sine squared 3x, cos squared 4x, sine 4x. Plus 60 cos cubed 4x times sine of 3x times cos of 3x. I would be fine with it left like this. It depends what you're expected to do. Maybe you'll be expected to factor. So if you were, we could factor a 60 out of both terms. I could factor a sine of 3x out of both terms, because there's a sine squared 3x here, there's a sine 3x there. I could factor a cos squared of 4x out of both terms. And when I factor that out, I will be left with negative 2 sine 3x sine 4x, plus when I factor this out of this term, I'm left with cos 4x and cos 3x. And you might see the order reversed so that the positive term is first. Both of these are considered equally simplified. It's just that this one is factored. Let's take a look at another example. In our next example, we have a quotient. So we want to know the quotient rule. Again, we can define our numerator, or u, and our denominator, v, and find the derivative of each. So u will be 1 minus 3 times, and I'm going to write it as sine of x squared so that you can see it's a power. And the derivative of that will be 0 minus 3 times 2 is 6 times the sine of x to the power of 1 times the derivative of sine of x, which is cos of x. V is cos of 4x, so v prime will be negative sine of 4x times 4. And I'll put that out front. Now that we have all of those defined, we can plug into our quotient rule. So the derivative of this will equal v, which is cos of 4x, times u prime, which is negative 6 sine x cos of x, minus u, which is 1 minus 3 times the sine squared of x, times v prime, which is negative 4 sine of 4x, all over the denominator, or v squared. Now we'll clean this up. So that's going to be negative 6 cos of 4x sine of x cos of x minus, I'm going to distribute this to each term. So I have a minus, and then 1 times this is a minus, so minus and a minus gives me plus 4 sine 4x. And then I have minus, minus, minus for this next term, so that's a negative 12 sine squared x sine 4x over cos of 4x, and I'll put the square there. There's nothing that I can really simplify. I want to point out that you may see slightly different answers when you look these up because the author may use some of your double angle identities, for example. So here, if we took a 2 sine x cos x, that's equal to sine 2x. So you might see things like that, and you might wonder where they came from. It could very well be that they've used an identity. All right, let's take a look at a few more. In this next example, we have y equals 5 times cos of sine of 4x. And the biggest mistake I see students make here is that they think it's a product. They see the brackets there, they see a cos. But we don't have cos of a function. We don't have cos of x, for example. We have cos of this. So it's not a product. It's a composite function. We have cos of another trig function. The outer function is the cosine function, and inside of that we have the sine function. So in order to differentiate this, we think of this as our u, so cos of u. The derivative of cos of u is negative sine of u. Then we multiply by the derivative of this. The derivative of sine of 4x is cos of 4x times the derivative of 4x, which is 4. So that one can be a very tricky one because students see it as a product rather than a composite function. Now we'll just simplify it. 4 times negative 5 is negative 20. Cos of 4x I'll write out front. And then I've got sine of 4x. So that would be the result. Let's take a look at the next one. There's two ways that we could approach this question. We could treat this as a quotient, and the same thing here. Or I can take sine out of the denominator and put an exponent of negative 1. However, be very, very careful when you're using a negative 1 exponent. Sine of x to the negative 1 is not the same as writing inverse sine of x. I'm going to avoid the negative 1 exponent just because of that confusion. We learned in a previous video that this means inverse sine. It doesn't mean sine of x to the negative 1. So I'm going to differentiate this using the quotient rule. So the quotient rule says you take the denominator, sine of 2x, times it by the derivative of the numerator, which is 0, minus 5 times the derivative of sine of 2x, which is cos of 2x, times 2, all over the denominator squared. I do the same thing here. I take the denominator, or v, cos of 3x, multiplied by the derivative of the numerator, which is 0, minus the numerator, 6, times the derivative of cos of 3x, which would be negative sine of 3x, times 3, all over the denominator squared. So I'm just using the quotient rule that I used in the previous example. Now we simplify this. Okay, that's a 0. We're going to have negative 10 cos of 2x over sine squared of 2x, plus 0 there, negative times a negative, and 3 times 6 is positive 18, sine of 3x divided by cos squared of 3x. You may find answers expressed a little bit differently than this because the author of the textbook might use trig identities to change the format of the answer. This would be correct, and if identities are used, it's correct as well. So just be aware of that in case you run into that problem. Let's look at one last example. With this next question, I wanted to include a question that involved implicit differentiation. So if you're asked to find dy dx, remember you're going to differentiate every term of your equation with respect to x. Here we have a product. We have x times the sine of y. So the derivative will be x times the derivative of sine of y. The derivative of sine of y is cos of y times the derivative of y with respect to x. Plus, now we use the rest of the product rule, sine of y times the derivative of x with respect to x is 1. So this is the result. These two terms are the result of differentiating that product. Plus cos of 2x, the derivative of cos of a function is negative sine of a function, times the derivative of 2x will equal 3x squared, plus the derivative of y squared would be 2y times dy dx. Now we want to combine the terms that have dy dx on one side and all of our other terms on the other side. So we're going to have x cos y times dy dx minus 2y dy dx will equal 3x squared. When I move this term over, it becomes negative, minus sine of y. When I move this term over, it becomes positive, and I'll pull the 2 out front. I have two terms containing my dy dx, so I'll factor dy dx out of both terms. Now I can isolate dy dx by dividing by this factor. And when I do that, this would be my result. So often when you're doing implicit differentiation, your derivative will be in terms of x and y. Practice, practice, practice functions involving cosine and sine functions. And in the next video, we're going to move on to the next trig functions. Take care.